All right. The next section we're going to do chapter 4, section 4, but this is the video part 2. Okay, this is part 2 of the video. Now, a normal curve or a bell curve. If you are studying or analyzing a huge amount of data, suppose that you're looking at the average sales, you own a store and you're looking at average sales per day, okay, for the past year. This would be a really good way to analyze your data, okay, or a really good way to predict the next year and what you're going to make the next year, okay, because this bell curve is true for huge lists of data, okay. It's for the most part pretty accurate for most data. We're going to actually conduct an experiment next week using the bell curve, okay, but for today we need to understand what it means, okay, and then you're going to use it in your homework. Now,
Can you write that down?
4 normal bell curve, yeah, you can. It's called the normal curve, or also known as the bell curve, because it looks like a bell. Now, the first thing you need to know is that no matter what, you always start in the middle with the mean. When you guys did standard deviation yesterday, before you found standard deviation, you always have to do what? Calculate the mean. So mean is always going to be in the middle. The mean of your data is always going to be in the middle. And then we have to think about the red part. Okay, the red part. You are going to have one standard deviation to the left and to the right. To the left and to the right of your mean. Okay, so we calculated standard deviation in our homework. Okay, we're going to go one standard deviation to the left, and it's going to hit this mark, or to the right. We're going to go one standard deviation to the left of the mean, and it's going to hit this mark. Okay, so you're going to take the mean, and you're going to add one standard deviation. Plus one standard deviation. And then to go this way, you're going to subtract one standard deviation. Now, why standard deviation? What is standard deviation? Before I keep going, let's talk about what does standard deviation mean. In your own words, what is standard deviation? Well, let's talk about it for a minute, okay? I'll come back to that. Just give me a second. Suppose that I have a graph, okay? Just any old graph. I'm going to sketch it. And let's say the average, okay, we'll talk about age in this classroom. Okay, some of you are like 18 in 1 month, 18 in 2 months, or some of you are 17 in 7 months, okay? Whatever it might be, the average is going to be about, we'll say 17 years old and about 4 months, we'll just say. Okay, I don't know if that's true, but we're just going to say that for the most part. Okay, and we'll say that this is 17 down here, and we'll say this up here is 18. Okay, and the average is right there. Now, if I were to go ahead and measure all your ages based on years and months, it would probably fall somewhere like that, right? I mean, I'm just taking guesses. I'm just bouncing up and down. Everybody, for the most part, is between 17 and 18. Some of you are a little bit above 18. Okay, but for the most part, that's where you're at. Standard deviation is this. If I measure the distance from each point to the mean, okay, the mean is the blue line. Okay, each point to the mean. I'm going to measure all those distances. So some of them is going to be 6 months. Some of it's going to be a year, some of it's going to be however many it is. I'm going to measure it. Do you guys remember when you found deviation? Okay, what was it, the third or fourth step? You took the mean and you subtracted from the number. Isn't that how you find distance, that black line? The distance of the number from the mean. You don't understand what I'm saying? The distance of the number from the mean. Well, standard deviation is just the average of all those black lines. If you take all those distances and you calculate the average, that's what standard deviation is. It tells me, is the average of all those black lines really, really far apart? Or is it really, really close? Are they all within 2 or 3 months? Or are they all within 9 or 10 months? Is the average, is it, where's my average at? Do we have really spread out data or do we have really tight data? Okay? The only thing that's weird about how we calculate standard deviation, okay, we have the square root of the sum of the deviation squared divided by the number. Well, to calculate average, don't you just add up all the numbers and divide by the number of values you have? Isn't that what average is? So why square and square root? Why is there a squared and a square root in there? Shouldn't it just be the sum of the deviations divided by the number? Isn't that what it should be if it's average? Why the squared and why the square root?
Get rid of the negatives?
Yeah, good. To get rid of the negatives. Because if you calculate deviation up here in our chart for age, are we going to have some negatives, which are below the average, and some positives, which are above the average? Well, if we square it, it gets rid of the negatives. And then what's the opposite of squared? Square root. So why would we do the square root?
To get it back to the original.
To get it back to the original one. That's the only reason it's there. Understand? I mean, for the most part, that's the basic reason why it's there. Because when you square it, it gets rid of the negative, and you square root it, it just puts it back. Okay? That's all you're doing. You find the average of the deviations squared, square root. Okay? Now, so let's go back to our normal curve. So when I look here, I'm just adding the average one time. And then guess what the green's going to do? What are we going to do out here to the green? We're going to add it twice. It's going to be one standard deviation, then two standard deviations. Okay, so I'm going to go ahead. You can write it one of two ways. You can say, well, you're going to add another standard deviation, or you can say it's two standard deviations away from the mean. Okay, however you want to look at it. Inside here, this is one standard deviation, this is two, or the whole thing is two standard deviations. Okay? And the same thing going this way. We're subtracting another standard deviation, or we're taking the mean and subtracting out two standard deviations. And then the blue, using common sense or using our pattern that we have here, we're taking out another, or we're adding another standard deviation, or it's 3 standard deviations away from the mean. Any questions so far? Now, what do those colors represent? Those colors represent percentages. Okay, percentages. Inside the red, okay, inside the red stands for 68% of the data you analyzed. 68%. So half of it, of that 68% is going to be on this side, which is what? What's half of 68? Yep, 34% on this side, and on this side, 34%. So 34% of all the data you're analyzing is going to fall within one standard deviation of the mean. 68%, 34% this way are going to be bigger than the mean, 1 standard deviation away from the mean, and 34% are going to be less than 1 standard deviation from the mean. The green is 27%. Okay? So technically, if you add the red and the green, 95% of all the data you're going to find is going to be between 2 standard deviations less than the mean or 2 standard deviations more than the mean. It's going to fall in here. So this, if I have to get 95%, oh, that should be green. Sorry, I'm colors here. Is going to be 13.5% here. And it's going to have to be 13.5% here. Because if I add up 68% plus the green, which is 27%, I'm going to get 95% of all the data. So 95% of all the people in this class are going to be within 2 standard deviations, right and left of the mean. And then the blue, 2% on each side. It stands for 4%. And that gets us up to 99%. So where is the other 1%? Where's the other 1%? Not in the middle.
The white.
The white. The white on the end. The 1% aren't even going to be, they're just going to be the outliers. They're going to be the ones that are just way out there. Like me, my age 30 is going to be way out here. Okay? So this is 0.5% are going to be way out there. You have 1% left, so you have half here and half here. Any questions on all the information I wrote down on that normal curve? Now, let's go ahead and try a problem. Okay, I'm going to try a problem. And it's going to freeze. Now, let's look at one of your homework assignments. Okay, we'll do the one we did together in class, even though I don't have it up here anymore. Number 2. Okay, do you remember the data we had for number 2? Okay, what was our average? What was our mean for number 2? Anybody remember? 5.9. 5.9. And what was our standard deviation? 1.3. Okay, so we calculated that when we did number 2 together as a class. Number 2 being 139. So, where does the mean go?
Middle.
In the middle. So right now, for this set of data, for number 2 in your homework, the mean is going to go right here, which is 5.9. And I'm going to put that in red so it matches the normal curve that I drew earlier. 5.9 is going to go in the middle. Now, what number is going to be in the first hashtag? And how do I know? Well, how did we calculate one hashtag over? What is it? What does your normal curve say? Plus 1 standard deviation.
So 1.3.
So yeah, so I'm going to add a 1.3 to 5.9, and that's what number goes here. What is 5.9 plus 1.3? 7.2. So right here, I'm going to put 7.2. I added a 1.3, 5.9 plus 1.3. Now, to go the other way, to the left, what do I have to do?
Subtract.
Subtract. You're going to take 5.9 minus 1.3. What do you get?
4.6.
Yeah, 4.6. Okay, smaller so I can fit them all. So I added a standard deviation and subtracted a standard deviation. Now what do I do next?
Subtraction.
Do it again and do it again. So do it 2 more times. So here, I'm going to add another 1.3. And I'm going to get 8.5. Goes right here. And then I'm going to add another 1.3 to get this one, and I'm going to get 9.8. Then I'm going to go do the same thing going the other way. Except I'm going to subtract. And take 4.6 and subtract the 1.3. And you're going to get 3.3. And then I'm going to subtract another 1.3. And you're going to get 2. Does everybody understand where I'm getting those numbers on the normal curve? Is there just 1 standard deviation, 2 standard deviations, and 3 standard deviations away? Minus and plus. Okay, now, I don't know what this data stands for, but I am going to show you how to use it really quick. Okay? What numbers fall between 2 and 9.8? What are we talking about here? What could we be talking about here? Suppose we're talking about grades. Suppose we took a 10-point quiz. Okay, a 10-point quiz. Now, we're just going to go ahead and we're going to say this. I mean, technically, grades usually hopefully are on the higher end. Okay, but we'll talk about grades here. Suppose we all took a quiz and we calculated standard deviation. Then I wanted to go ahead and use your quiz scores based on your mean and your standard deviations. Okay, and I wanted to calculate it for if I were to give it to all students in the entire school. Okay, technically if they all had business math. Okay, so how many kids do you think we have in the school? Yeah, let's say we have 800. Okay, 800, I think we have more than that, but we'll just say 800. Okay, how many of those 800 students are going to get higher than a 7.2 out of 10? You're on the right track, not 34%. How many of those students are going to get a grade higher or greater than 7.2 out of 10? Not 16%. Think about it. Okay? Now, where on this curve is the grade higher than 7? Oh, yeah, you're right. It is 16%. Okay? There's 7.2. A grade higher than 7.2 is going to be over here, right? A grade higher than 7.2 is going to be over here. What percentage of the bell curve is that?
13.5.
13.5 is between here and here. If you look at your chart.
You always do 10%.
Always. Plus 2% is from here to here. And then we have how many out here? 0 plus 0.5%. So we're going to have 16% that's going to fall to the right. So 16% are higher than 7.2. Well, what is 16% of 800 students? And how do I find it? Yeah, take 800 times 16% or 0.16, and what do you get? How many students would I expect to score higher than a 7.2? 128 students. That's how you can use the normal curve to predict the future. So, or predict a huge amount of data. Okay, so for instance, if you knew the normal curve and the standard deviation for, I don't know, for the entire, we took a random sample, we could make predictions over the whole world. We could make predictions for all the United States if we know how many people in the United States. We just multiply it by that percentage if we have a good set of data. And it's going to give you a pretty good. Now we're going to go ahead and we're going to do an actual project using this, but tomorrow you have homework that you need to do with this. Okay? I'm going to give you the whole period. It's not due till Monday. You can start it now. I would recommend you start it now, or actually the bell's gonna ring, isn't it?
Yeah.
Okay, it's on.